This chapter is going to be on, or this section out of the chapter is going to be on cancer. I know cancer can be a tough topic to talk about. My father had thyroid cancer a couple years ago. He's in remission right now. But I know this can be a hard topic for anyone. Everyone's going to be affected by cancer in some point, whether you know somebody or you develop cancer yourself. So this can be a really tough chapter. But it's better to know about cancer and to know really the details and why somebody develops cancer and what you can do from a young age to try to help prevent yourself from getting cancer. Knowledge is a power there. Cancer is uncontrolled cell growth. This is when mutations on genes that control cell growth are going to be either overexpressed or not expressed enough. We'll talk about those two different types of genes here in a little bit, but there is a great variation among the cancers. It's not like the polio or disease or like COVID, where it has basically one strain or has one virus. There are many different types of cancers, and that's why it's so deadly. It's not just one; it's like a whole host. It's like a whole. It's almost like a whole branch of science that looks at how uncontrolled cell growth occurs. Different types, benign growth. This is tumor that lacks ability to migrate. The big thing with the cancer, one of the big things is when it starts moving and migrating to different parts of the body, that's when it becomes really tough to fight. Malignant, that's when a cancer starts to spread, and it's just very hard to fight the cancer at that point. Usually when there's unfixable DNA damage, the cell goes through apoptosis. However, if that doesn't happen and the cell does continue to divide, that's called cancer. Now, a couple of different features about cancer. Cancer lacks differentiation, which means they don't overall contribute to the function of the tissue. So, like, let's say you have liver cancer. The cancer there, if you think like, oh, it's just more liver cells. No, not necessarily. Those cells that are cancers don't have differentiation, which means they don't, again, aid in the liver function. So it's not like there's more of that organ. It's that those cells are just not functioning. They also have an abnormal number of nuclei. You can see here there's going to be several nucleuses within the cancer cells, and that's just a very telltale sign of cancer cells. Cancer does not undergo apoptosis, like I mentioned before. This is that controlled cell growth. And what they do is the cancer starts to form these tumors. These are locations where you're going to get an abundance of these cells that are undifferentiated, and they're not going to aid in the function of that organ. We can see here that one cell becoming many more cells and becoming many, many, many more cells. What happens is when these start to metastasize, they start to go through different circulatory system pathways where they're going to migrate to different portions of the body. And once that starts happening, it's like fighting a wildfire. Fighting one wildfire is bad enough. If you have one wildfire that spreads to different locations, though, it becomes even more difficult. So we want to stop the cancer from migrating to different locations throughout the body. Like I said before, metastasis is when that cancer cell is going to start spreading to different portions of the body. Angiogenesis, this is the formation of blood vessels to that tumor. So, like I said before, the cells that are that are actual cancer cells, they're not going to help with that organ that it's located in. However, they're also going to start sucking away the nutrients, and actually they can trick the body into thinking that cancer cell or that cancer tumor is part of your organ. So it's going to actually supply it with blood. Once it starts to get supply with blood and energy, it can grow even quicker and quicker. So these two things are very deadly when it comes to cancer. Oh, let me go back and let me show you that angiogenesis. You can see here, these localized tumors are going to send molecules and say, hey, we need some supply of blood here. We're not getting enough. And then once that happens again, you're going to start feeding those cancer cells even more nutrients, which is just bad.
Talked about how these mutations are going to occur on certain genes that are going to either stimulate or they're going to repress the cell from going into the cell cycle. Proto-oncogenes. These are genes that they're going to make proteins which want the cell to go through the cell cycle. I have the analogy here of a gas pedal on a car. When you press on the gas pedal of the car, you want the car to move. You want the car to go. Same thing here. We want the cell cycle to begin. However, you also have these tumor suppressor genes. These are like the brakes on your car. These are genes that create proteins that stop the cell cycle. So we do have two types of genes here. They're either going to promote the cell cycle or they're going to prevent the cell cycle. Mutations on either one of these genes can cause cancer. You can see here this analogy. I love this analogy with a car. Cancer is being the wall. Usually you have these gas pedal genes that are the proto-oncogenes that, hey, like, start the cell cycle, or tumor suppressor genes that, hey, stop the cell cycle. But when either one of those is mutated, those genes, they become either the oncogenes here or an inactivated tumor suppressor genes, and that can cause that cancer. Now, thankfully, cancer rates on very early on in life are very low. If you think about it, you haven't gone through a lot of mitosis, you haven't gone through a lot of cell division. It's when we get to about the 50, 45 age range where you start really seeing a dramatic increase. And yes, guys, this affects more guys than girls, but just overall, we see a huge increase when we get to the later ages. So that's when a lot of people develop cancer. I'm not saying that you don't develop cancer very early on. There is a lot of childhood cancer out there, and we're fighting it as best as we can at our hospitals and with our medical community. But it is very rare that you get these childhood cancers, but they are also very deadly as well. Yeah, so this is just a chart that's going to show you and track how much cancer there is in each age group. I mean, you can look at the chart; it's very interesting to see the differences.